Yeah, it's a very honor to present together with Seadrill here from oil and gas industry, real world project together with Cedalo. A quick introduction from our side. So as you heard, my name is Tobias Mühnicke, leading the Edge business unit at Portainer. Edge means for us everything related to IoT and in particular industrial IoT. Have a industrial background, so worked at VW, so Volkswagen, for around 7 years, managing industrial projects together with a joint venture of AWS and Siemens. And we found out that more and more companies ship their software as a software container, and normal traditional businesses are challenged by that because they do not have the corresponding infrastructure. So we evaluated different container management solutions, and then later on decided to purchase Portainer, work together with Neil, the CEO of Portainer, for 1 year there, and then switch positions from a 600,000 employee size company to a 60 employee size company. And yeah, working there for a couple of years now. And Philip, feel free to continue.
Thanks for that. I'll try to keep it a little bit shorter. But anyways, hi, I'm Philip from Cedalo. I'm very honored also to be here. I have a background in industrial engineering. I've been actually basically, I'd say, like almost half my life working at the intersection of manufacturing, engineering, and working with data, and particularly over the last 8 years on and in MQTT, and really across many different industries, in particular in manufacturing, also very different manufacturing sites, many different manufacturing processes all over the world. And as MQTT has basically taken up quite a bit over the last years, obviously, I'm quite excited to be here and yeah, present with you here basically what Seadrill did. And with that, I'd hand it over to Matthew.
Thanks, Phil. It's been a quite exciting year. A lot of complexity of onboarding vendors from my side, but we finally made it to this point. My name is Matt McClendon. I run the reliability department at Seadrill. That is nested within our rig innovation and technology group. And one of my core taskings is essentially data availability and novel application of proven methodologies from outside our industry. My background's a pretty varied one, from mid-90s sysadmin in the Linux and Unix environments to military avionics, and then 16 years in oil and gas now, ranging from offshore field instrumentation all the way up to superintendent, and then now my current role. So essentially the right person to have all the disciplines to put something like this together. So essentially, Seadrill and our competitors and friends, it's not too aggressive, Stena. Our problem is that our industry is somewhat insular, both in our technical expertise and the vendor pool and landscape that is available to us. And that incurs a high development cost and very bespoke solutions when it comes to an OT environment. It also has the burden that the enterprise ISIT that support us from an onshore basis tend not to understand the application of what we're asking for as operational personnel. Most of our onshore technical people come up through a pipeline of operational personnel offshore, and so that kind of further commits us into that's how it's always been done, even though in a safety sense we consider that a very dangerous statement. With those established systems, we find that when we go to add or augment, we get just astronomical pricing or subscription models that seem predatory, CapEx and OpEx associated with provisioning an OPC UA stream. Adding a tag to one will incur a price that is as much as a reasonable car. And we prove that solution. One client wants it, we want to deploy it across a fleet. That's no discount, incrementally multiplied. So the idea here is to, my group runs a couple of products. Our core one that I maintain is called Asset Lifecycle Management. It is a predictive and real-time condition-based monitoring program that we run to be able to defer our capital equipment beyond the OEM's calendar-based recommendations. We are the only one of our competitors that does this within our industry, and it is within our guidelines. No one's just ever bothered to push it. So This is a huge cost savings from day rate loss mitigation to maintenance time to personnel offshore. It just reduces complexity. So we just took 4 assets into the Brazilian market, and all of them did not do what is previously assumed as being required maintenance to go into operation beyond their 10-year normal life cycle overhaul. So the vessel there on the left is the West Saturn. That's where our use case is going to be at. And essentially, to augment this program, we already have a pretty robust analytics stance, but we very frequently hit a use case where we can paint a reasonable picture, but to get the full context and be able to plan appropriately, we're missing key metrics. It could be any number of things. It could be operational, it could be environmental, it could be a sensor that's just not critical to that tool's function, but would paint a great picture for being able to intelligently maintain it. So we onshore, with our SMEs that handle our data systems, tend to have limited manning. And so we went to our real-time analytics and performance platform and asked them, hey, we want to add field devices. Do you have capacity to do that? And it was a vehement no, because that is represented by one person who is doing awesome, but does not have time to take on more responsibilities. So I sought out to look at what it takes to expand that. We started brainstorming some ideas, had a couple vendors for a specific scope do quotes to add 6 flow meters to our gensets for the purposes of energy efficiency and a emissions monitoring prototype that we were implementing. And the quote came back at, to integrate into a legacy control system, almost $300,000 for one vessel, one single implementation. So the idea is that we want to decentralize from not only the hardware that's required, we want to focus on standardization, we want to move away from the burden of integration with our legacy OEM control systems, and we want to contextualize this data with the data sets we already get through that common pipeline. So the idea is that it doesn't matter if it comes from, we cross-compare control systems, so why not cross-compare with something we've implemented to our legacy systems. So the idea is that to de-risk the approach, because just like I imagine the majority of the people in here, we have an ingrained fear in putting TCP/IP on a control system in general, and take a pretty aggressive stance at limiting that exposure just as a matter of principle. So the idea here is a full chain, including discrete instrumentation that is specific to this system, to be able to paint a contextual picture with data that we already have. Our Halo goal on the roadmap is a fleet average cost of sub $500 per point of measurement aggregated onshore into our existing analytics systems. The other benefit is that along with these high CapEx values that we get pitched, we tend to, there's a lot of front loading on the engineering. Everybody tends to come to us and say, hey, we have all this expertise. No, we've never worked with oil and gas before, or yes, we have, but we've never done what you're asking. Sure, let's have an engineering conversation that takes 3 to 6 months. Essentially, we're teaching them what the use case is, and then they deliver a tender package, drawings, we review it, we give engineering input. It's a very hands-on process. And then we come to implement. If it's not something that's turnkey enough that our crew offshore can install, they need field personnel that are qualified to fly on a helicopter offshore. Some countries that's easy, some it's hard. It's a long process. And then in the Brazilian case, the work visa process is minimum 6 months. And then until it's live on the rig, we don't even know if it's going to work. And a lot of the time it won't. And then there's a lot of API and interface troubleshooting that will happen. That's a large cascading man-hour burden internally for us. So the apples to apples is that essentially we front load all the engineering for this. We standardize and template both the hardware with support from Wago. We essentially part numberized some standard junction box layouts that they constructed for us to our specs. We enter those in our maintenance system, and we say every rig needs a box with an edge PC in it, and that serves as the footprint for the central broker. And then we extend the system with field I/O that can be addressed with containerization also. So in this case, we're using a PFC 100. The PFC 200 is also an option, and then you have a few more in the pipeline. But I mean, the intent is to chase this to the bottom of reliability. So I mean, we have a roadmap to use the Jetson Nano Supers that just got announced. We're looking at other PLC vendors. I'm content to go all the way down to industrial Raspberry Pis. Just given that we've de-risked every part of this. At the point that we have a use case that is critical data, we have a plan for implementing high availability and stepping that up to higher criticality serving. So this is our basic architecture. The idea is that this is incremented at a minimum, 1 per vessel. Right now, we have an operational fleet of 17, and this will essentially, like, we proof out the concept, and we'll issue a bulletin, and every rig will buy at least this footprint. The use case for the prototype is adding CTs to dynamic loads on 2 of our switchboards to be able to paint a better energy efficiency picture within those individual consumers. The idea here also with extensibility is we're front-loading a lot of the cost with the edge compute, and then as we find more use cases from both onshore and offshore stakeholders, we expand horizontally within this architecture. So on the short list, we have some visual data acquisition plans. We have, we're going to be implementing a LoRa gateway for valve position feedbacks and process telemetry to essentially give drill crew members a visual representation of what a valve lineup is for safe operations. And then we're also looking at interfacing for data streams from legacy OEMs. So putting an edge device in, having it just do a single point-to-point network or serial interface to a atypical OPC UA, and have that pulled into the MQTT pipeline.
Yeah, Matthew explained in a couple of words, right, that he's highly relying on containerization, so microservice architecture. And we saw in the previous architecture a couple of components, right, so applications like the Mosquito MQTT broker. And in order to scale this, right, he's using in his project Portainer. And we are a simple fundamental container management platform that can manage applications across different environments, so can be on the cloud, on-premise, what we call them data centers, and also at the edge, so industrial PCs, and also PLCs, no matter which technology you're using, so can be Docker, Docker Swarm, Podman, and also Kubernetes. And very important from a strategic point of view, we are not catching our customers in kind of a vendor lock-in, like cloud providers are doing this, so it's you can use us on any cloud or on every cloud, and also on-premise if you want. So we run fully air-gapped, and yeah, as you can see, there's also not a mistake on the button, right? So it's we are widely spread, so with lots of downloads. Next slide, please. This is a typical industrial IoT reference architecture. I won't elaborate too much on it. Just that you can see we consider also the different layers in a typical industry, right? So could be a cloud, could be a central data center on the top, then DMZ, and then finally the factory network with all the different components. And normally our customers are using our central user interface, then in the DMZ, and then our agent, which is then allowing the customer to manage the corresponding applications in the factory network. And this, next slide, please. Yeah. And this is, of course, just one component of an industrial IoT project, but it's not a solution, right? So no one is just buying a container management platform, and this is why it's so essential to also partner then with other companies so that we can, so we of course not dependent on one device manufacturer like here, Vargo, but it's always good to have some friends in the market, and then value-added resellers, system integrators, and also independent software vendors that are facing the challenge that they're shipping their software as a container and then selling to companies that do not have the corresponding container management platform, and then we can bundle it. And one of those independent software vendors is Cedalo, and that's also, so MQTT broker is a critical component in IoT and industrial IoT projects, and this is why we also have partnered with Cedalo and with Philip, and also implemented then joint projects together.
Thanks for that. I'm happy to introduce us, Cedalo, a little bit to you. And the thing is really, what I want to focus on is that our mission is really to empower you to shape your digital future by providing and creating the leading data backbone for IoT and connected solutions. I think until today, most of you probably have never heard of us. Amy gave it a nice introduction. Also, Walker was so kind to mention us a couple of times. But we are actually the team behind the open source mosquito broker. In fact, also Roger, one of my co-founders, kicked off the project. He's also here at the fair, so please feel free to stop by and have a chat. I'm also quite happy about the fact that we're actually the most widespread broker out there with over 600 million downloads, probably the most used one out there.
Yeah, I mean, if anybody's playing with Mosquito or with MQTT, you've used Mosquito. I mean, the fact that Philip and Roger, who are the founders and developers of Mosquito, which by far has the most installations in the world, it's not even close. Mosquito is the de facto MQTT broker in IoT without exception. Honestly, it's an honor to have you here. Cedalo is Mosquito Pro. I'm always telling Philip, hey man, you should have made it Mosquito Pro, not Cedalo, because no one knows that it's Mosquito Pro. But Philip, Roger, it's an honor to have you guys here because, hundreds of millions of people have used your product. It's kind of crazy.
Thanks for having us. Yeah. So you heard it. You probably all of you have touched it, have seen it already, and the fact is, nevertheless, that most of your use cases, projects, and the MQTT infrastructure that you actually want to build probably requires something that no open source broker can actually give you. And these are going to be things like high availability. You want to have high availability, redundancy actually, because the thing is that you really want to make sure that your MQTT infrastructure is always up and running and operational. Then maybe you're going to run into problems like scalability if you have many assets or high throughput, but most likely it's going to be the case that you have a multi-broker infrastructure. So what is that? I mean with that you're basically not going to have one broker only or one broker cluster, but rather you're going to have several brokers that are connected with each other and form a distributed MQTT infrastructure. So what does that mean? That means that you're probably going to have a plant with several shop floors, and on the shop floor, each shop floor has its own network. So in the end, probably you're going to end up with at least one broker per shop floor that's going to connect to a plant-wide broker. And then if you have a site with several plants, the plant broker is going to connect to the site broker, and then maybe regional, and then global, actually. So in the end, you're going to end up with a tree-like structure, and in the end, really also a distributed MQTT infrastructure. And the thing there is that you really want to make that secure and have security in place, because you won't be working on that alone. So you want to have control over who sees what, who can edit what, and who can change what. And all of that, obviously, in order to put it later on into a unified namespace, to visualize that, to see your data, to interact with it, and use that unified namespace. However, nevertheless, one thing is for sure as well, and that is actually that nothing there stands alone. So MQTT in itself is not the goal. It's not the end of the whole show. It's just a crucial piece that's connecting to other things. And what are these other things? Typically, the database like MongoDB, TimescaleDB, Google AlloyDB, or streaming services like Apache Kafka, Google PubSub. Again, so it's always a piece of something. And over the whole thing, you want to have the observability. You want to have monitoring in place. You want to know how healthy is my infrastructure. So health stats under progress. What are my clients actually doing? Is somebody walking off and doing something stupid or so? So you want to be always in control over that. And all of that and more we actually give you with the Pro Edition and our platform there. And a subset of these features are also being used by Seadrill. And with that, I'd hand it over to Matthew again.
Straight to it. We started off very simple in our implementation for the demo. Basically to prove out the concept, its reliability, and then we have almost immediate plans to grow into high availability both in our offshore and onshore brokers. As soon as we started internally communicating the solution, we got a lot of stakeholders coming out of the woodwork. So I've kind of already covered the legacy versus current deployment, but basically most of the year that we've been working on this has been onboarding vendors from Seadrill's process side. The actual development time, I finally got left alone in the last 2 weeks, and this is the most robust it has been. So the actual configuration and setting things up is very fast. And then once we templatize it, it's minutes once we deploy hardware to a rig. versus 6 to 18 months in a conventional manner. So for the demo, essentially we're going to deploy the broker into our Wago edge computer here. It already has 2 subbed clients to it. One is the telemetry module on the power supply, and one is the PFC 100. So once the middleman is up, you'll see the MQTT packets coming through that broker, and then we have it publishing the entirety of its topic structure to the cloud instance. And we'll show that chain and then some simple telemetry off the power supply. A lot of the effort that goes into this and its planning and the development with it is to make it as repeatable of a process as we can from the get-go, so that when it does go into production, it's not something you have to get behind the pane of glass and get in the nuts and bolts to get something up and working. And so a lot of that will involve GitHub pipelines. We're not a software development house, but part of this will be implementing, at least at a basic level, a robust CI/CD process that works behind it, so that when we do extend the solution, it'll be as code and not really getting in and customizing as it were. Looking forward, like I said, we intend on expanding this. It's already gotten a ton of attention. The approval of the prototype, if all green, and it's immediate budget allocation is what I'm being told. So my company is very interested in it, and I have LoRa devices sitting in my office that have an immediate use case once we get the footprint on the trial rig. After the demo, you can come visit us at booth 13. We can go into many more details. I have a couple of our internal magazines you can go through, and we can demo the unit multiple times. It's very quick and easy to process. So we can go with that. We can go to the demo. There you go. Okay, so this is a Portainer cloud instance that we've set up specifically for the conference. And I took my existing compose files and supporting files and set up a Git repo, private one. Our intention for production is to have an internally managed private repo that we self-host on our infrastructure. So essentially here you can see each node with the edge device and the field device, which represents the PFC. Both of those are set up as edge agents in an asynchronous mode. Within here you can see the stacks that we've built for all of the cloud-based services. So that represents Mosquito and the Grafana and Prometheus stack that we'll display the trends on.
Hold on a second real quick. Can we put his screen on the center screen too? Can we do that? Is it possible to have it on all three? Thank you.
So yeah, these are our, at least for the purposes of the demo, our infrastructure is also a cloud VM that we're running Docker on in our Azure environment. And then, as I said, all the field devices, this normally sits on my desk for testing purposes, will be discrete hardware that is only running Docker, Portainer, and then whatever stack that we're using. So
could you quickly go into the configuration and just show, just so they understand that it's basically a compose file behind?
Some of this is so here's this is set up for the conference. Like I said, this is the only adjustments to this were adaptations to Portainer's cloud infrastructure. Actually, I have here you go. In this scenario, we've put everything in a tail scale sidecar arrangement so that the physical location of the device and environment is irrelevant. And our plan B is I have a little cell hotspot there in case the network wasn't available or wasn't working. That's advantageous. Like I know that my production environment uses a zero trust network, and so I'm kind of prepping for that kind of infrastructure integration for when I hopefully pass this off to ISIT for management. So I wanted the functionality to be in there, but essentially I'm taking each individual container, I'm locking its network config to the tail scale, and then it's presenting as a FUDN and IP in the tail scale network. It's still peer-to-peer WireGuard though, as far as latency goes. And And then from this structure, like one of the pipeline and deployment advantages is being able to put in files that I choose to map. So to ensure that the tail scale FQDNs are working, I'm posting a customized host file to the Mosquito container. Also, I made a specific ACL for only allowing MQTT clients to post by their device name as far as the topic structure goes, and then by username, because I have a couple of container health checks for starting order to go through. And then the Mosquito configuration file for the cloud instance is really just the permissions is the main customization there. And then from the edge deployment, I have the bridge connection for the broker-to-broker arrangement, and then also permissions at that layer. And then for provisioning sake, the environment variables as far as like the key for onboarding into tail scale, our license keys and things like that. And all this can be pulled by Portainer from the Git repo as part of the deployment process. So we can go back to that. Yep. So that's the cloud one. So we're going to go ahead and, within the edge functionality, which if anybody's got the free that they use at home, you got to go enable this. I didn't know that before I started talking to these guys. All the fun stuff is hidden behind the edge functionality. So in here, we're utilizing a couple things, although I'm going to attempt to wrap this up into the CI/CD pipeline. So edge configurations is essentially a way to archive dependency files and transfer them to a Portainer device on the edge and have it adhere to a directory structure that you define within the transfer. Another one is edge jobs, where you can send, right now in the prototype phase, we're using this for host alignment. So I have a bash script that I put into the edge job, and essentially it goes through and like identifies the Linux kernel, the device name, some available physical devices, and then out of all that, plus its Class C that we have, because we define each of our rig assets by the Class C section of the network, IDs what rig it's installed on, and then changes the host name to a progressive one ending in the last section of its MAC address. And then we pipe that into the Portainer onboarding script and reinitialize the environment so that we get the standard naming convention and everything's, we can tell where the deployment is without being there, or having a rig crew member tell me the MAC address or some other involvement from them. It's very versatile. I love those two sections. So for the edge deployment stack, we're just going to add the stack. In this case, it is what we would consider our edge. Here we've set up two groups, one for edge and field. You can also build applicability hierarchies with the tags within those to be able to unify a deployment across device types, which we will be using a lot as we roll out common solutions to multiple rigs. So here is our actual, let me grab my. So you can also, I have the meta-specific credentials saved in here. We put in our repo URL. It's pulling the heads main as far as like what your name in the repo versus main and master. You put in what your driving compose file is. So if you have service-specific ones all housed in the same repo, you could reference those here. We're mapping physical files into the container. So we're actually going to pick just an existing folder to mount those files in so they can be mapped to the internal of the container. You can also go through this, and a lot of this can be used as far as the structure of the GitHub repo to take individual configurations and tune that to complementary devices. So you could have a bunch of configs that are named or within a directory structure to deploy to certain identifiers based on tags within that edge group. So there's a lot of versatility in here, and a lot of this is like things that post-prototype we will go through and essentially tune up our deployment process to where it's just dead simple. Like describe the deployment process in a paragraph is kind of what I'm going for. So a graphic, a paragraph, update this file, hit deploy and push. And here's where you can do the file name based on Edge ID, the folder based on Edge ID. So, and that's why I put a lot of the effort I did into standardizing like how I'm pulling the node IDs and publishing those based on physical location and kernel version and things like that. I'll throw my env from here. So there you can see it pulls in all my environmental variables. For the edge deployments, especially for limited connectivity, our primary path for our enterprise network is VSAT, so high latency and high likelihood of just dead packets. It's great fun. So you can have the option to try and pre-pull the image before it deploys the container and retry the deployment, which is huge as far as our ensuring reliability of the deployments for an offshore environment without having to, again, ask a guy who has other duties, hey, can you go check on this machine? Hey, can you go reboot it? My idea is that we put these physical boxes on the rig, they live within their discipline, which is instrumentation, electrical work, and then they're done. They can walk away. And we shouldn't have to ask them to mess with it anymore. And we're gonna hit deploy now. And this process is essentially setting it to where the next time the asynchronous agent checks in, it sees that it has a task to complete, and the progress of that task will be shown right here. Let's see. I do dead time, but here we are. There we go. So you can see there is the image pull. And there's our successful stack deployment. And then here is the management center, which is part of Mosquito Pro. And I can go into my topic tree. This is reading, our arrangement is a whole broker as a client to the cloud broker. So there you see the topic name based on the host name. And process data is actually our power supply. So you can see device OK, millivolt value. And then here you see our data is back online on the Grafana trend. So that, like even, say we just loved spending a ton of money on expanding our control systems, just that process, once they put a field rep on board the ship, could be weeks to months before the data's live and streaming. So if nothing else, hitting a button and being able to deploy and have a live data stream in minutes is industry breaking, essentially. That's it. We can go to questions now.
Yeah, absolutely. Thank you so much. So if we could, it'd be great to get the QR code up there again. While that's going, I'm going to ask you a question, the question that all the MCs are asking. So for your use case, pretend that you didn't use Portainer. What would be the next best way to achieve all the things you did, and then explain why using Portainer and Cedalo was better?
Within our industry, the margins are pretty thin as far as implementing new tech. Like I said, it's been a huge burden on our back over the years as far as the CapEx and complexity of install. As part of this development process, we essentially did an off-axis health check. Like, are we doing the right thing? Just go to a system integrator blind. We gave them like a genericized version of the functional design spec that I wrote for this and had them bid it with the same field devices and didn't give them any constraints except for that we wanted it repeatable and extensible. That was it. And what we got back was a Siemens system with licensing, and it was, north of $150,000 for one rig. So whereas about 60% of the cost that we did for this prototype, which is, I think our total spend on this is $68,000 right now, and that includes $17,000 for field personnel to physically install it so that I don't have to use the rig crew. And then we front-loaded our Portainer license for enough for the whole fleet, and doubled up the expensive part of the field deployment on the rig. So we're actually going to have 2 edge computers just for testing purposes, but it wouldn't be required. And we're still under 50% of what the comparable system was for a single rig's implementation. So it's the value proposition of pulling it internal and just using proven off-the-shelf software solutions is immeasurable in most cases. Like we could pitch this to every. If this works and we extend it and it becomes the norm for our company, that's awesome, and we'll be ecstatic about that. If it terrifies our industry's vendors into having a more collaborative approach when engaging with us, that would be great too. So we'll take either one.
That's awesome. Thank you for sharing that real world experience and those real world cost savings. All right, so next question. Why and when should one prefer to use Mosquito Pro over Hive MQ when it comes to a broker?
Sure. I'd say that there's there are several points when it totally makes sense, but maybe to go into 2 of them. I think one that we already established, and thank you also on that point for you, Walker, is you've all worked with it. So you're familiar with it, all your engineers are familiar with it, you know how it works and that it works. So if you ever ran into a problem with that, let me know, but I'd be so confident that you probably didn't, otherwise we would have known that. And for that reason, it's also completely battle tested on the core broker itself, because if something doesn't work, we know it right away. That's for sure one of the things. And then one thing where it also stands out as a whole technology itself is its efficiency. So it's very, very efficient in the sense of it has a small footprint. You don't need much CPU power, you don't need much memory, and that opens up many more use cases because you can put it on low power devices, small devices, and Walker, especially yesterday, mentioned that a couple of times around cloud costs. You're going to have a much smaller footprint for the same capacity, basically, what you can achieve in the cloud itself as well. And that's simply because the core broker is written in C, a little bit of C++, whereas the HiveMQ broker is written in Java. So that's essentially where this power boost comes from.
To expand on that a little bit, the reason that these conversations started is because I use Portainer and Mosquito at home for home automation purposes. So it is functionality, familiarity, and the pipeline of open source use case into enterprise. That's like before the conversations were even started, we knew that we were looking at these 2 solutions. And
I want to just chime in on the Mosquito Pro piece because I think it's important. There's one that Philip didn't say. I love both, so I'm not picking one over the other, honestly. There are definitely places where I'm going to go Mosquito Pro versus HiveMQ. If you want to know, I'll talk about it. I'll tell you privately. But there is one. Mosquito Pro is easier to the startup. Investment in labor is easier when you land Mosquito Pro than it is with HiveMQ. A lot of HiveMQ's configuration is in XML files, so you have to browse the XSDs to understand all of the arguments that you need to put in XML. So it can be a little bit longer to land an enterprise implementation of HiveMQ than Mosquito Pro. So if you want shorter time to value, if shorter time to value in this case is very important to me, then I'm going to pick Mosquito Pro, assuming I don't need some of the other enterprise features that I would be looking for that are unique to HiveMQ. But yeah, the short time to value is a big one on the enterprise scale.
So, in the theme of ProveIt, of course, I know this is a bit of an unconventional session, but can you still tell us a bit more explicitly, what does Portainer cost? What does Mosquito Pro cost?
So for this prototype, I've been given the green light.
Wow, okay.
So the Portainer license is, for the core license, it was $15,000 and then $55 per edge node, of which they have a minimum spend, which I believe is 50 nodes. That's enough to cover our fleet implementation, at least for the next year or 2. If we go gangbusters, then so be it. But we'll be fine for now. And then we baked in some engineering hours for support. And due to my familiarity and the simplicity of interacting with the product, those will end up being like hearts and minds like familiarization talks for like our management as the program rolls out, which we've already used a couple hours for just to demo it to our electrical and controls group. And then as far as Mosquito Pro, we did 4 brokers to start at $4,000 per broker node in a managed environment. So right now, the demo is only managing one of the brokers, but for visibility and monitoring, and when we transition to high availability, those will all be wrapped into the management center for monitoring.
Awesome, thank you. So besides observability, what other advanced edge use case is Seadrill looking into?
Lots. I have about a 20 bullet point list of just wild ideas that we've had. There's a ton of really they sound really boring as far as use cases goes, but they have a huge capital cost or timing cost. So a couple of them that we're looking at is we monitor a lot of condition assessment points that are physical measurements that happen on a 12-month cycle as part of our predictive maintenance program. And those are kind of like a health check that we have the crews do or third parties do, and then it gets reported into our maintenance system. So some of it's going to be elimination of those manual measurements. So for instance, one measurement we take is the sheave profile on our crown blocks. And we are looking at a couple LiDAR solutions and some other things like that. And essentially that would enable us to take a device that gives you a TCP socket or a web socket of some sort and pull straight from that and give it to the broker. Or run a little control loop in a container and post it to the broker. So the huge advantage here is that the use case is, it's not irrelevant, but it's not what we need to focus on. Every use case is enabled by having that pipeline there and available for use to where we can just prototype quicker. We can try an idea without the infrastructure being a huge part of risk in trying something that's never been done before. So.
Cool. So I'm going to pick this question. So most take communication to the internet for granted. Can you share a unique problem and creative solution that arose due to not always having good internet on the rig?
So one of my first asks as part of the initial conversations with both Portainer and Cedalo is the worst I've ever experienced. Our VSAT's on KU band. We do have a secondary connection through Starlink on all of our assets now, but we tend to not have the enterprise traffic going through there. So KU band can absolutely get disrupted by thunderstorms, and does. The longest time I've ever been without connectivity on a rig was 7 days. And so the idea of the broker-to-broker arrangement within Mosquito Pro is to have data resiliency and reconciliation to replay those captive packets back to the cloud broker and backfill, essentially.
Awesome. All right, last fun question. How easy was it to get the rig through TSA?
So I'm from Houston, so I drove. But
Answer, all right.
I have carried way weirder stuff through the airport for the oil field. So it's not as hard as you think. Commercial invoices will go a long way at getting you through an airport.
Awesome. So unfortunately, we are at time. If you have any questions, I strongly encourage you to go to their booth and keep the conversation going. Going to hand it over now to my other co-MC, Jeff Winter, on Dell Stage 1.
Great job, guys. Great job.